Thermodynamics in Biosystem, Module 4, Properties of Pure Substance, Segment 3, Property Diagrams. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. Previously, we have discussed about phases of a pure substance and phase change processes. In this segment, we will discuss about property diagrams. Figure on the right shows a TV diagram of constant pressure phase change processes of a pure substance at various pressures. Let's consider the case of boiling water as discussed in the previous segment. As the pressure is increased, the saturation line continues to shrink, and it becomes a point when the pressure reaches 22.06 MPa for the case of water. This point is called the critical point, and it is defined as the point at which the saturated liquid and saturated vapor states are identical. The critical point properties of water are 22.06 MPa, 373.95 degrees Celsius, and 0.003106 m3 per kilogram. At pressures above the critical pressure, there is not a distinct phase change process as shown in the left figure. Instead, the specific volume of the substance continually increases, and at all times there is only one phase. Above the critical state, there is no line that separates the compressed liquid region and the superheated vapor region. The saturated liquid states in the figure can be connected by the saturated liquid line, and saturated vapor states in the same figure can be connected by another line called the saturated vapor line. These two lines meet at the critical point, forming a dome as shown in the middle figure. All the compressed liquid states are located in the region to the left of the saturated liquid line, called the compressed liquid region. All the superheated vapor states are located to the right of the saturated vapor line, called the superheated vapor region. In these two regions, the substance exists in a single phase, a liquid or a vapor. All the states that involve both phases in equilibrium are located under the dome, called the saturated liquid vapor mixture region or the wet region. The PV diagram. The general shape of the PV diagram of a pure substance is shown in the left figure, whereas the figure in the middle shows a PV diagram for a substance that contracts on freezing. Figure on the right shows a PV diagram for a substance that expands on freezing, such as water. Under some conditions, all three phases of a pure substance coexist in equilibrium, as shown in the top right figure. On PV, these triple phase states form a line called a triple line. These states on the triple line of a substance has the same pressure and temperature but different specific volumes. The PT diagram of a pure substance is shown in this figure. The diagram is often called the phase diagram since all three phases are separated from each other. Vaporization line separates the liquid and vapor regions, and the melting line separates the solid and liquid regions. These lines meet at the triple point where all three phases coexist in equilibrium. The vaporization line ends up at the critical points because no distinction can be made between liquid and vapor phase about the critical point. Substances that expand and contract on freezing differ only in the meeting line on the PT diagram. The PVT surface. The state of a simple compressible substance is fixed by any two independent intensive properties. Once the two appropriate properties are fixed, all the other properties become dependent property. The PVT behavior of a substance as a surface in space as shown in the figure. T and V may be viewed as the independent variables and P as the dependent variable. All the points on the surface represents equilibrium states. The single-phase regions appears as curved surface on the PVT surface, and the two-phase regions as surfaces perpendicular to the PT plane. The PVT surface presents a great deal of information at once, but in thermodynamic analysis it is more convenient to work with two-dimensional diagrams such as the PV and TV diagrams. In the next segment, we will discuss about property tables. Until then, I am Yusuf from Institut Teknologi Bandung.